Hello and welcome to Elementary Algebra. I'm your instructor for this course, Amy Fuchsteiner, and we are starting Chapter 6 today. Chapter 6 is about factoring. Factoring in general is, oops, hello, we didn't need to do that. Factoring is the process of determining what term or terms were being multiplied together in order to get the product that you are currently looking at. What are the building factors themselves are the building blocks of the numbers, the polynomials, the terms that we'll be looking at. When you break a polynomial into its base parts, this is known as factoring the polynomial. And when you find the greatest common factor, you're essentially finding the one number or term or polynomial that is in both parts of the polynomial or terms. So you're comparing two different polynomials or terms and finding the biggest part that exists in both. All right? You have found greatest common factors several times with numbers, but we're going to go over that particular skill because we're going to extrapolate on it. We're going to build on it and use it for finding the greatest common factor of polynomials and of terms. Okay, so here we have the numbers 45, 60, and 75, and we would like for you to find the greatest common factor for these numbers. There's really three different ways to go about it that I am aware of, well, that I favor. There's probably more, and I'm probably aware of more, but there are three different ways that I favor. The first, I'm just going to call a guess and check method. If you have some skill and some practice with mental math, the guess and check method will work best for you. I'm looking at the three numbers 45, 60, and 75. And because I have some skill and practice with mental math, I know that 15 goes into 45, 60, and 75 right off the bat. I know that no other number bigger than 15 will work. Nope, it won't. So right now, I'm saying the GCF, greatest common factor here, is 15. Will everybody be able to do that using mental math? No. No, they will not. As a matter of fact, most people probably cannot. Most people probably cannot use mental math to find a greatest common factor. Those of us of a certain generation where the mental fluidity of mathematics was prized, yes. Those where it was not, no. So when you don't, what do you do? All right. Assuming you're not just going to Google it, what skills do you use? Because those are the skills we will need. And the idea is this, that you take the 45 and you break that into 5 times 9, and you break that 9 into 3 times 3. And you list the factors of 45 as 3 times 3 times 5, right? You do the same thing for 60. 60 is 6 times 10, which is 3 times 2 and 2 times 5, or 2 times 2 times 3 times 5. Those are all the factors of 60. And then lastly, you would list all the factors of 75. 75 is 3 times 25. 25 is 5 times 5, or 3 times 5 times 5. And you notice that all of these numbers are divisible by 3. This has a second 3, but none others do not, so I would not use that. All of these numbers also have a 5. Only the 60 has 2, and nobody has a second 5. So my greatest common factor would be 3 times 5, which is indeed 15. This is probably the most common way for most people to find a greatest common factor for large numbers or large parts, is to simply list those factors and then find those factors that are in all of them. And once you have found all of the common ones, you multiply them together to get the greatest common factor. All right. With the second problem here, I believe I do have a typo. I believe this was a 36. Not for nothing, but I believe that was a 36, a 54, and a 90. And again, if you have some fluidity with the mathematics, you know that the greatest common factor here is 9. Actually, I think we can go even bigger. I think we can go 18. right? I believe we can go 18 with that. Now, if you don't have fluidity and you don't like this particular method, there is the, I don't know what to call it. It's sort of like an upside down cake. It's sort of a prime factorization method. Basically, what you do is you take a look at the three numbers like this and you say, okay, well, 2 go into all of them. Yes, 2 goes into all of them. 2 goes into 36 18 times. 2 goes into 54 27 times. 2 goes into 90 45 times. Now, will 2 go into all of them again? Will only go into 36. It won't go into any of the rest. So 2 I can't use again. So now I'm going to bump up to 3. 3 goes into 18 6 times. 3 goes into 27 9 times. 3 goes into 45 15 times. Will 3 go into all of them again? Yes, it will. 3 goes into 6 twice. 3 goes into 9 3 times. And 3 goes into 15 5 times. At this point, there is not a common factor that goes into 2, 3, and 5. Sometimes there is, sometimes there isn't. But there's nothing more that goes into 2, 3, and 5 with the exception of a 1. And once you get to a 1, you're pretty much done. So this tells me that my greatest common factor is 2 times 3, which is 18. All right. I finally broke it. There we go. Okay. Right? We can use this same method when we're dealing with terms and variables, x's and y's. So now we have x and x squared. Notice that if you're looking at an x and x squared, the greatest common factor is x. Why? Because x is just x, and x squared is x times x. So what's in both of them? Just that x. So the greatest common factor for x and x squared is just an x. If I've got an m to the 6th and an m to the 4th n squared, an m to the 6th is, well, it's just m times m times m times m times m times m, 1, 2, 3, 4, 5, 6. And an m to the 4th n squared is m times m times m times m times n times n. So what's in common? The only thing in both of those guys is 4 m's. So my greatest common factor here is m to the 4th. If I have an 18y squared and a 45y, as far as the numbers go, for 18 and 45, both of those are divisible by 9. And for the y and y squared, y is in both of them. So my greatest common factor here is 9y. Right? If we're looking at 12 x to the 4th, y to the 6th, 18 x to the 5th, y to the 4th, and 30 x to the 3rd, y to the 5th, looking at just the numbers, a 12, an 18, and a 30, I notice right off the bat that all of those are divisible by 6. So 6 is the number that I'm looking for. Then I have an x to the 4th, an x to the 5th, and an x to the 3rd. Out of all of those, I have an x to the 3rd. X to the 3rd can come out or can be a part of all of those. I have a y to the 6th, a y to the 4th, and a y to the 5th. Of those, y to the 4th is in all of them. So I need a y to the 4th. This gives me a 6x to the 3rd, y to the 4th. So there's a couple of things, a pattern or two that I hope that you're noticing when we're dealing with the variable. Here I had a y to the 2nd and a y, and it ended up using a y. Here I have an x to the 4th, an x to the 5th, and an x to the 3rd, and I ended up using an x to the 3rd. A y to the 6th, a y to the 4th, and a y to the 5th, and I ended up using a y to the 4th. So what does that tell me about the power? When I pull a variable out, what does that tell me about the power on that variable? Is it the highest or is it the lowest? So the numbers will do the same, but hopefully you've noticed a pattern when it comes to the variables, right? Okay. How do we use this greatest common factor? Well, essentially we use this greatest common factor to undistribute. I mean, there are fancier ways of saying it, But what we're going to do essentially here is we are going to undistribute the greatest common factor, right? So here's what we want to do. In problem number 5, I have 6f plus 36. As I look at these, a 6f and a 36, I notice that 6f is 6 times f, and 36 is 6 times 6. So I can, out of both of these terms, pull a 6, and then I'm left with f plus 6. I have just undistributed that 6 out of both of those terms. This is actually distribution, but we tend to think of it in the beginning of your algebra career as reverse distribution because we're actually doing what you know is distribution in reverse. This is factoring. Okay, there are no other common factors. This is as far as it can go. If we look at problem number 6, for problem number 6, we have 48s squared t squared minus 84st. Okay, 48 and 84. I can pull a 2 out. I can pull a 4 out. 8's not going to work. So I think the highest I can go here in terms of numbers is a 4. We'll see if I'm right in a minute. Then I have an s squared t squared, and here I have an st. So I can for sure pull out an s, and I can for sure pull out a t. I'm not sure that 4 is right, but that's okay. There's a way to fix it if I'm wrong. All right, so then I'm going to undistribute that. So 48 divided by 4 is 20. Oh, no, not 20. 1. 4 divided by 4 is 1. So that's 12. And then if I have an s squared and I take out an s, I have an s left. T squared, I take out a t, I have a t left. There we go. So I've got 12st minus 84 divided by 4 is 21. St, s divided by s is 1, t divided by t is 1. They're gone. Okay. So I look like I've got 4st and then 12st minus 21. The problem here is that 12 and 21 have a common factor. So 12 and 21 are both divisible by 3. So how do I fix this? Well, I pull out a 3. So now I've got 4st, and now I'm going to pull out a 3, and that's going to leave me with 4st minus 7. So now I can multiply that 4 and that 3, and I got 12st, 4st minus 7. And that should do it. How do I know if that's right? I multiply back. I mean, essentially, we're dividing. That's why it comes after the division part in chapter 5. Because essentially what we're doing is division in sort of a more mental, mathy kind of way. Yeah. So if I want to multiply this back, I do 12 times 4, which is 48. Check. S times S, which is S squared. Check. T times T, which is T squared. Check. 12 times 7, which is 84. Check. ST. It worked. So I'm good. All right. I'm going to get rid of this pink just because I feel like it's not the right color to be doing this in. All right, so now I've got a 14 x squared y squared minus 7 x squared y plus 21 xy. And I have learned from my many years of algebra that if there is a 7, it's likely 7 is going to be able to come out. So I should be able to take out a 7 out of all of these. I am. Then I've got an x squared, but oh, that's just an x. So I can only take out an x. I've got a y squared, but those are just y's, so I can only take out a y. That's going to leave me with a 2x y minus 1x plus 3. So my two factors here, well, actually I have four factors. I have the 7, the x, and the y. Each one of those is being multiplied. So each one of those is a factor. And then I have 2xy minus x plus 3. And if I want to check and see if that is correct, I multiply back. 7 times 2 is 14. X times x is x squared. Y times y is y squared. 7 times a negative is a negative 7. X times x is x squared. And the y is just coming along. 7 times 3 is indeed 21. And the xy sticks on the end. Yep. Okay. All right, what do we do for factors of? Oh, number 8. This is a good one because these are hard to see. But once you get used to seeing them, it's like, oh gosh, of course. So for number 8, I have 6z times the quantity z plus 5. Then I have plus 3 times the quantity z plus 5. Now I know that for very many of you, your gut instinct here is to go ahead and distribute. That would be the wrong move. And here's why. You may not have noticed, but I'm going to go back to this lovely lemon yellow that I left the other day, and I'm going to pick it up again. Because if you see, here you have 6 times z plus 5. And here you have 3 times z plus 5. Do you notice that this z plus 5 is exactly the same factor in both of them? Those parentheses are exactly the same thing in both. So I am going to pull that out front. I'm going to pull this set, z plus 5, out front. This is a set that goes together. I know it's a set that goes together because it's inside parentheses. And then I'm going to take the remaining pieces that are left and put them in parentheses, 6z plus 3. I got the 6z from there. I got the 3 from there. Now I have two binomial factors, much like we were doing at the end. Well, actually, it was kind of the middle of chapter 5, right? And this is it. This is factored. See, this is the hard part. I've just told you that 6 is 2 times 3. And what you want to do is multiply these back together. Nuh-uh. I want to know what the factors are. My two factors are z plus 5. That's factor 1. And 6z plus 3. That's factor 2. This is factored. I don't want to do any more. I want to leave it. Okay? All right. What do we do with number 9? We'll come back to those. This will be important. So we'll come back to that. Number 9 is a negative x to the 4th minus 3x squared plus 5. Can I pull anything out of a negative x to the 4th, a 3x squared, and a plus 5? Well, I was really happy about the x's, and then I realized this one doesn't have an x, so I can't pull that out. 3 and 5 do not have a common factor. There's nothing I can pull out of there. So what do? Well, I don't like that leading negative. So what we'll do is we'll pull out a negative 1. And that will leave us with an x to the 4th here. And if I pull a negative 1 out of this, that will be a plus 3x squared. And if I pull a negative out of here, that will be a minus 5. Sometimes the only common factor we have is a positive 1 or a negative 1. In this case, I could pull out a negative 1. We often do that when the lead is negative, but we don't do it many other times. So if we're starting with a negative, we will pull out a negative. You see this also in problem number 10. In problem number 10, you have a negative 24ab to the 4th plus 12a squared b cubed minus 18a cubed to b squared. So I'm going to pull out a negative because we led with a negative here. Then I've got a 24, a 12, and an 18. I'm going to pull a 6 out of those. That's my greatest common factor. Then I have an a squared, and an a cubed, so I can pull an a out. I've got a b to the 4th, a b cubed, and a b squared, so I can pull a b squared out. Then I am left with negative 24 divided by 6 is a 4. A's are gone, b's I need a squared. 12 divided by negative 6 is a minus 2. A and B. So I got, what do I multiply an A by to get an A squared? I need another A. What do I multiply a B squared by to get a B cubed? I need another B. Now I've got a negative 18 divided by a negative 6. That is a plus 3. What do I multiply an A squared by to get an A cubed? That's an A by to get an A cubed. That's an A squared. And B, to get a B squared is just a 1, so I will leave it. Negative 6AB squared times. All right. So just as a reminder, do you know how many factors are here? There are actually 1, 2, 3, 4, 5 factors in this polynomial. Just negative 6 times A times B times B times this parentheses, 4B squared minus 2AB plus 3A squared. So there are 1, 2, 3, 4, 5 factors. The factors are the things being multiplied together. So even though that B is squared, it counts as 2 different factors, that A, that negative 6. So just as a point, there are 1, 2, 3, 4, 5 factors in this one. There are 2 factors in this one, 2 factors in this one, 2 factors here. This guy has, let's see, the 12 would be a factor, the S would be a factor, the T would be a factor, and the parentheses would be a factor. So this guy has 4 factors, and this guy has 4 factors, the 7, the X, the Y, and the set of parentheses, right? Okay. All right. I think this is the last goal. Yeah. What is this? I don't know what this is. All right, so we want to factor by grouping. So factor by grouping is, well, there's a strategy to it. Factoring by grouping is when you rearrange the parts to find a common factor and then you factor that out. So basically, when we're doing a factoring by grouping, no, that's not what I wanted to see. Sorry. When we do a factor by grouping, we want to rearrange the terms with the common factors. There isn't necessarily a right and wrong way for each one of these. Sometimes it's who sees it first. You know how sometimes if you're like playing a video game, there might be more than one way to the treasure, and it's just a matter of which way you saw it first. It's not right or wrong as long as you get to the treasure. Some ways are more efficient than others, but it's not a right or wrong kind of thing. So our strategy here is to look at the terms that are listed in the problem and then to decide whether or not we need to regroup them. We need to rearrange them. Sometimes we will, sometimes we won't. Okay. We're going to group them in twos. I won't say twos, I'll say pairs. And then we want to factor those out. Okay. So what does that look like? I don't think 14 makes any sense here. I think I left a typo. That's all right. It happens. Okay, so I've got 3 examples for us to practice with in our factoring by grouping. All right, our first example, we have a 9x plus a 9y plus xy plus y squared. Do you see groups, pairs of terms that have a common factor? Lord knows I do. I see that if I group these 2 together, I can pull out a 9. Right? So that's what I'm thinking in my head. I look at that right away and I think, oh, okay, I can pull out a 9. Then I have to look at this other pair and I have to sort of think to myself, is there something I can pull out of here? And I'm thinking it. I'm not necessarily writing it. So I've got an xy and a y squared, and I think, okay, yep, I can pull out y. Right? So I know that these two are grouped in a manner in which I can pull something out of the first pair and something out of the second pair. So I'm going to do that. I'm going to pull a 9 out of this first pair, undistribute it. I'm going to factor it out. And that's going to leave me with x plus y. Right? I'm going to keep the plus. And then I said I was going to pull out a y, so I'm going to pull a y out of this. And that's going to leave me with another x plus y. This is a perfect situation. Because now that I've factored out that 9 and that y, I see that what I have here is the same in both of those. So I can take that x plus y and I can factor it again. Factoring out the common factor of the factors. Oh, that's confusing, Amy. Yeah, I'll see if I can figure out a better way to say it in a minute. So now I'm going to take that x plus y and I'm going to pull that out front, and that's going to leave me with 9 plus y. This is like the one we just got done doing. Well, we didn't just get done doing it, but it's very similar to the one we did a minute ago. So now I have two factors, factor 1 and factor 2, and they're both binomials. This is a binomial factor. This is a binomial factor. When you factor by grouping, you should get two binomial factors. Right? If I want to check it, basically I'll do the first, that's 9x. I'll do the outside, that's xy. I'll do the inside, that's 9y. And I'll do the last, that's y squared. If I rearrange this, I do get 9x plus 9y plus xy plus y squared. And that is exactly what I started out with here. Okay? Perfect. All right, let's look at the next problem. In the next problem, which is number 12, I have a q to the 6th plus 25 q to the 5th, and I have a plus q plus 25. Okay, couple of things. This one doesn't need to be rearranged, but you may want to do that. And if you want to rearrange it, you would probably, I'm just thinking, you would probably put those 25s together, right? So I'm just going to switch these two places. So I have a q to the 6th plus q plus 25 q to the 5th plus 25. Right? Because now I can, this is a little bit awkward, but I can pull out q. And if I'm looking at the other pair right here, I'm going to pull 25. Right? So if I pull a q out, that's going to leave me q to the 5th plus 1 plus, and if I pull a 25 out, that's going to leave me q to the 5th plus 1. Okay, but Amy, where are you getting the ones? Here's where I'm getting the ones. I got q, I'm going to pull a q, so q divided by q is 1. I got 25, I'm going to pull a 25. 25 divided by 25 is 1. Okay, plus I need something to multiply back by. Q times q to the 5th is q to the 6th. Q times 1 is q. I need to do that q times 1 to get that q. All right, but now as I look at this, do you see how what's inside the parentheses, what's inside these groupings is exactly the same? So that tells me I can pull this out front, q to the 5th plus 1, and then I'm left with q plus 25. And I have factored it. I have factor number 1 as q to the 5th plus 1, and I have factor number 2 as q plus 25. It's a beautiful thing. Beautiful, beautiful. Okay, but what if there's negatives? No worries. No worries. Okay, so this one is set nicely. I can see that from the first grouping right here, I'm going to pull a -6. Why a -6? Because it's leading with a negative. When it leads with a negative, I pull a negative, right? I'm not saying you have to. I'm saying it's good practice. Lead with a negative, pull a negative, all right? The second one is a -12ax minus 12ay. I'm going to pull, since it starts with a negative, I'm pull a negative. I got a 12, and I think I can pull an a. Yep, that's in both of them. So I'm going to pull a -6 from the first pair, and I'm going to pull a -12a from the second pair. So this is going to give me a -6x plus y. It's got to be plus, because negative times a positive will get me that minus sign. Then I'm going to pull a -12a, and that's going to leave me with an x. And since I pulled a negative, this will switch again to plus y. Do you see how that's x plus y then in both of them? So I factored, but I can factor the common factor out of these two. So now I can pull this x plus y out front, leaving me with a -6 minus 12a. Oh, but I want to fix this too. Do you see how this has a negative in both of them? So now I'm going to, this is an extra. This is extra. This is an extra step. This right here, I'm going to pull a negative. So that's going to give me a -1. I'm going to put it all the way out front because it's multiplication and order does not matter. X plus y, 6 plus 12a. Some people would just write this as a negative. X plus y, 6 plus 12a. And that's okay. That's all right too. Ooh. Sometimes you think you have all the common factors and then you find an extra one. It's okay. It happens. Just like when you're reducing numbers, you know, like if you've got, let's say 25 over, no, that's not going to work. I don't know. But sometimes when you're reducing, I can't come up with something on the top of my head right now. But even sometimes when you're reducing, let's say you had 24 over 18, right? And let's say you recognize right away that those are both divisible by 2, and you get 12 over 9, and then you think, oh yeah, they're also both divisible by 3. So even though we only divided by 2 in the first step, we can still do a second step and divide by 3. So in this case, I thought I had it all factored out, and I didn't. So I just needed to do it one more time, remembering to put the negative. Okay, you don't have to do it in one fell swoop. You can do it in steps, and you will still get to the right answer. All right. If you have any questions on those factoring skills, let me know. We're going to go ahead with section 6.2 in order to use some of the things that we've just learned. All right, if you've got any questions, please don't hesitate to reach out to me or to the Math Center. We all want to see you succeed.